Host Dr. Andres Plazas, and as always, we're going to bring you a roundup of today's news from space and astronomy. So today we have some exciting news coming from Mars. As you know, for decades we have been looking for liquid water in Mars, and we have found evidence that point that in the past there was indeed water. There are valleys or basins that tells us that there might have been liquid water in the past, but the conditions have changed a lot since then, about 4.5 billion years, about the same age as the Earth. And scientists know that nowadays it's not likely. We are not likely to find the liquid water on the surface of Mars. However, we do know that there are subterranean ice deposits in Mars, and today, actually, the Italian Space Agency has announced that researchers have detected evidence for signs of a large stable body of liquid water locked underneath about a mile of ice close to the south pole of Mars. The observations were recorded by the Mars Advanced Radar for Subsurface and Ionosphere Sounding Instrument, or MARSIS for short. And this instrument, MARSIS, is collected this evidence from orbit. It is on board of the European Space Agency Mars Express spacecraft that was launched about 15 years ago in 2003, on June of 2003. And the way the data were collected, it was just by transmitting any pulses of low frequency of electromagnetic waves towards Mars, and then some of those waves are going to interact with features at or below the Martian surface and then reflect back to the instrument. And in that way, it can prove the geological composition of the planet. So the concept is very simple. In principle, you just point it toward the ice and then you see what bounces back. But in practice, of course, it was a little bit more complicated to get this data. Because MARSIS, the instrument, it spends a relatively little time above the geographical place of Mars where these ice sheets are. It is called the Planum Australe. It's the southern polar plane of Mars. And so what does this mean? It means that the researchers could only listen for the echoes just once in a while, right? Periodically. So it took them many readings and many years to get a clear picture of what actually lies hidden underneath the planet's southern ice cap. So we know that they started taking data in about 2012 for this particular measurement after they did a software update. And they took data for about 3.5 years. And then something after they were done with their analysis, or during their analysis, they realized that there were bright reflections in the radar signals. And the researchers called these bright reflections actually a well-defined anomaly. It wasn't something out of the ordinary. And these anomalies were actually about 12 miles across and several feet deep. As I said before, roughly 1 mile beneath the surface of the polar ice cap. The surface of an ice cap, it tends to reflect the radar waves in a more strongly way than regions that are below it. But then after multiple passes, MARSIS has been able to detect these uncommonly strong echoes that originate from below the southern pole. So this is, in a way, well, not that surprising, because we know that from analysis of subglacial lakes on our own planet, so we know that there are lakes underneath the Antarctic and Greenland ice sheets. And we know from this type of data and experience that water reflects radar more strongly than rock and sediment. In fact, actually the researchers point out that the radar profile of this region of Mars that they have imaged resembles even those subglacial lakes here on Earth. Then, of course, researchers have looked for alternative explanations for the bright signals, of course, because this is an indirect measurement, and we need to be skeptical especially we are gonna make such a claim. So one of the alternatives that the scientists posit is that there might be a frozen carbon dioxide layer above or below the polar cap, and this could also produce readings like the ones that they have observed. Although they don't give the details in the press release, but they say that in their analysis, the researchers have deemed these and other alternative explanations less likely than the presence of actual liquid water. So of course, in the future, we're gonna have to obtain more radar observations, and yeah, so hopefully this will shed light on this particular question, and of course on other questions that still remain unanswered. So, for example, it is still unclear how the water remains liquid at temperatures that are tens of degrees below 0 Celsius, below the freezing point. So the researchers say that the answer could lie in the existence of some minerals or salts in the water, such as magnesium, calcium, and sodium salts, which are already present in in the Martian rock, and they have dissolved in the water, and that they actually lower the freezing point of water. So another question that the researchers have is that for future observations is they want to know if this lake is just a single occurrence, and to say if this is the case, if you only find just with this one lake, then this would be this would have an implication that this lake is an effect of a residual decay of some hydrothermal vent or some thermal irregularity in the crust. But then they say that if, on the other hand, we were to find that Mars possesses not only one but many subglacial lakes, that would definitely change the ideas that we have on the geological history of Mars. Um, because this would imply that if we have several lakes, this would suggest that the conditions necessary for the existence of these several lakes are not so rare. And if those conditions have persisted throughout the planet's history, then subsurface reservoirs of liquid water could serve as a bridge to the early environment of Mars, or some sort of a time capsule that could contain information about those periods when Mars was a warmer planet, a wetter planet. And then, of course, we have the biggest questions of all. Of course, we get all excited about this news of water is because we want to know if there's life in the waters beneath Mars. You know, we want to know if there's life outside the Earth, and we know that water is a fundamental element, of course, for most of the water on the Earth. So some of the researchers say that sure, of course, it's certainly possible that there might be some type of life in this lake that they have discovered. Um, because, well, they point out, of course, you need three basic things for life: liquid water for the life as we know it. You have energy sources, and you also need a biological seed, or the spark of life. So they point out, the researchers, that well, with this new discovery, we already have the liquid water, and we have seen energy sources like leaching minerals, or that we already know that Mars has. Um, about the biological seed, well, that's a more tricky question, right? But the researchers also point out, well, if it happened on the Earth, then maybe something similar could have happened in Mars. So this is a very exciting discovery today. It was just released a couple of hours ago, and yeah, very looking forward to how this develops. Then I also wanted to talk about two more stories today. One of them related to intelligent life. So this news comes from the scientists from the SETI Institute in Mountain View in California. The SETI, SETI, Search for Extraterrestrial Intelligence, I think. And this is a kind of a particular story because they actually have, I didn't know this, they actually have an alien detection scale. And this is a study that was published in the International Journal of Astrobiology. And the press release tells us that this is a scale that was actually first developed in 2001 in Rio. I think there was a conference in Rio or something, and it's called the Rio scale. And they say that it's a tool that is used by astronomers that are searching for extraterrestrial intelligence to help communicate to the public how excited they should be about what has been observed. So it might sound silly at first, but then you think about a little bit further, and it makes sense to be prepared to this kind of events in case of something like that should happen. This type of a scale actually measures the consequences for humans if the signal is from what we deem an intelligent alien form. And it also tells us about the probability that the signal really is from aliens and not from some natural phenomenon or human-made, which has happened in the past, of course, that we think that some other civilization is talking to us, but we actually end up figuring out that it's some natural event, some radio source or something like that. And this is a scale that goes from 0 to 10, and you can see it right there in the on the screen. And you can think of it as a Richter scale for earthquakes, right? And in the study, they also point out that it was necessary to redefine this type of scale because of the changing nature of the media that we have today. Now, the growth of the 24-hour news and the landscape of the social media. And there are also more efforts. There has been an increase in efforts to detect extraterrestrial intelligence by the teams all around the world. So this is actually a scale that it must remain relevant when communicating to the public about alien signals. Yeah, so this is an international team of researchers that revised this Rio scale, and it aims to bring consensus across different academic disciplines when classifying this type of signals, and has the purpose to calibrate the public expectations of a reported signal, and also to educate the public as how to actually the SETI scientists actually evaluate this type of signals from initial detections to the various, of course, vetting processes and confirmation processes that are needed to determine if something is from a signal is coming from extraterrestrial intelligence life. So yes, and then they finally point out that of course it is very crucial that when we talk about something so hugely significant that it would be as the discovery of intelligent life beyond Earth, then we should do it in a clear and careful way, and this is one way of quantifying that. This type of a scale, they call it Rio 2.0, allows us to rank a signal in a quick way, in a way that the general public can easily understand it and help us keep it like in a reliable way, like so they can actually know that it's coming from a source that they can actually trust, and they have actually thought about how to explain this to the public before. So I thought this was an interesting story, and I'm pretty sure this is just a small part of all these preparations and serious research that is going on, and efforts to try to find what we call intelligent life outside of the Earth. And this is particularly important because, of course, we know that there have been, of course, lots of stories, and there's a lot of speculation, and we have this longing desire within us to say that, or to think that we are not alone in the universe. But as scientists, we should be skeptical, we should be methodical, we should be, of course, we should be looking for life outside of the Earth, of microbial life to what we call intelligent life or developed life. And we are doing it, but we should do it in a careful way, in following the scientific method. We should acknowledge that so far we have no evidence for any sort of life whatsoever. And I always sometimes when I give talks to the public about, they tell me, "Do you think there is life outside of the universe of not?" Like, well, that's when they ask you, "Do you think?" You can say whatever you want, of course. But I like to point out that there are actually researchers that are thinking hard about these type of questions. Historically, of course, we have the Drake equation, we have the Fermi paradox, and we have been thinking about in ways of quantifying this particular question, of course. But at the same time, we should be prepared, but we should be careful and skeptical and just always demand evidence, and that should apply for everything you do in life. Pre- Demand evidence of whatever people tell you. Anyhow, so that was interesting. And yeah, the last story that I wanted to share about was related to galaxy formation again. So this is a story about a team of astronomers that have discovered a new way to actually look more into galaxy formation. They have published a study in the astrophysical journal Letters, and then for the very first time they have used the Keck Observatory to examine a small young galaxy that is located about 10 billion light years away from the Earth. And this is a distant galaxy that is very faint and very hard to study in detail. But it's a young galaxy that it makes it an ideal candidate to learn more about what galaxies look like shortly after the birth of the universe. And this is a particular galaxy that is giving off, the gas of this galaxy is giving off a special type of light. And what is this means that the gaseous halo surrounding the galaxy, they glow with a particular ultraviolet wavelength, which is called the Lyman-Alpha Emission. And there are several theories that say about what produces this type of Lyman-Alpha emission, but most of the theories say that this light probably comes from a star formation in the galaxy that is being absorbed and re-emitted by gas in the halo, and this way we can learn more about the gas in the halo. So this team actually have used one of the newest instruments in Keck. Is called the Keck Cosmic Wave Imager. It's an integral field spectrograph that we have mentioned in the past in the daily spaces, that basically is like a sort of combination of imaging and spectroscopy, and in every pixel you have an spectral analysis of the galaxy. So in the end you end up with a 3D cube data of information. And it is important to study this type of galaxies that have all this gas that is emitting in this particular wavelengths, because as we know, most of the matter in the universe is dark matter, of course, but then we have a few fraction of what we call the ordinary matter, and within that fraction of ordinary matter, most of the ordinary matter in the universe is not in the form of stars of planets, but it's in form of gas. And most of that gas actually does not exist in galaxies, but around and between them, which is what this type of galaxy is allowing us to study. So yeah, so they say that in this analysis that this is the first of their kind. So far it has only been tested on this galaxy, but of course they warn that we still need to wait to study more galaxies to see if the behavior that they observe from this particular galaxy is typical or not. Actually the data from the team suggests that the galaxy is surrounded by this gas, but it has an spherical outflow of gas that has significant variations in the density and the velocity of itself. So they point out that using this technique of the Lyman-Alpha emission and further data with more galaxies like this that are already difficult to find, then we can figure out about the nature of the dynamics of this gas. And this is why it's important to have this type of cutting-edge and state-of-the-art instruments. As you know, the Keck telescope or teleobservatory is one of the best telescopes in the world. It's in Mauna Kea in Hawaii, and it's constantly obtaining and new instruments. A lot of the universities that are part of the consortium of Keck, such as Caltech, they continuously develop state-of-the-art instruments to try to push the boundaries of this type of observations. So yeah, I think this is what I had to say today, and I was very excited about the news of Mars, and very intrigued about the other two news, especially the SETI one. But yes, I'm curious to know what you guys have to say, and I'm gonna take a look at the chat right now. So hello everyone, and I'm gonna start by saying hello to the usual suspects. DPI 209, we have Paranor 001, we have Uncle Bill Druin. Hello. Hello Guido B, Guido underscore B. And hello Larry, Minasan, Ohio. Guido B points out that Mars Express is the workhorse of all the Mars orbiters. Yes, that's true. I think this is the one that also found like ice, like water in the form of ice. Sounds like science fiction, except it's science fact. Yes. Yeah, it's pretty cool. And I also find out that the way when I was studying as physics and then in grad school, then as you get more into the details and all this stuff, you start to learning things that is like, now this can be real, but it's pretty cool, you know, like to learn, and then every day you have discoveries like this, and yeah, it's slow but steady, but pretty cool. Even if there isn't Martian life, it'll make colonization easier. That's what Paranor 001 points out, and yeah, that's one of the, of course, ideas that we have in the back of our minds that eventually we might want to move there. Certainly Elon Musk and other people and NASA as well. But yeah, we have thought about, of course, moving to other places in the solar system, and Mars definitely is a candidate. And finding liquid water there, it's certainly promising. I wonder what Percival Lowell would say to this. Yes. Then hello Del1337. Hello Hannes Verb. I can't pronounce your name either. um, has ever been a 2 or 3? I don't know. This is related to the SETI news. I can't remember exactly what the question is related to. But Paranor 001 points out about the wow signal. Yes. Okay, you're talking about the scale. Sorry, my bad. Well, I don't know. Yes, as I was saying, this SETI scale was kind of news to me. Should have figured out there was something like that. And that's what it caught my attention when I was reading the press releases. So it would be very interesting to try to classify in a retroactive way, like to look into the past and see how these other signals that we have observed so far would lie on this type of scale. So yeah, I don't know. Maybe I don't know. Maybe the wow signal we could put it as moderate. I don't know, but here I'm just speculating. And I didn't read the actual paper, but hopefully I'm hoping that the researchers have, and I'm pretty sure that they have more serious criteria than what we us are trying to do right now, just by looking by eye. The goal of this is to try to be less subjective and more objective. But that would be very interesting to know. How would they classify? Hannes Sorvorpet comments, and I wonder if intelligent life would necessarily create an economy to support technological innovation. Yeah, that's a very good question. We don't know. We actually try to look for what we know, which is our own example, and it could be a very biased example. And that's a very valid question. We don't know if there is like a certain convergence in the history of other civilizations. Um, it doesn't, well, as far as we know, and we have this is as an assumption when we study physics, and as far as we know, the laws of physics in the visible universe, and so far as we can see, the laws of physics, they're valid, right? They think of them as universal, and we have tested them, and we think that they are universal. So then, based on that idea and that assumption that has been tested, we assume that it might be plausible that other civilizations might discover this similar type of laws of physics, and then who knows? Maybe they could also develop um, a similar type of civilization. But this is a very interesting question that would have to do with biological evolution, like biological drives. Like then we start to think about like why do we invent cars? Why do we invent planes? Why do we invent such and such object? So the answer to this question is like, okay, we want to move from one place to the other or make it easier. We want to improve our quality of life, and but will another civilization have those kind of needs? And if so, will they be able to develop a similar type of technology that we have developed that produces electromagnetic waves, or not? Or maybe is that something inimitable? It's like if you have another civilization that has found the same laws of physics that we have found in Maxwell's equations, will they necessarily converge into the same type of technology that we have converged after we have understood those laws? I don't know. And at this point, I'm speculating, but I'm pretty sure that there are ways to quantify. It is tricky. That's why this is a very hard question. So, but I'm pretty sure there are researchers that are trying to quantify this and to put this in solid and robust grounds. And coming up with this type of scales is one of those steps. Twitch is twitching. Yes, I think I observe. I also see that here. So I don't know why. Some other times the signal is good, but yeah, I don't know. Hopefully, it gets better. Humans use barter all the time, even now. I don't think a society based on barter is making many radio signals. I don't know what barter is. Maybe I should look it up. Um, if we do pick up a signal, it would probably be a few millions old, and we would not be able to answer. That's another good point. No, the vastness of the universe, and then, as far as we know, um, there is a limit given by the speed of light. That give it a limit in the way which transfer information from one point to the other, and that's given by the speed of light in vacuum. And even so, that would take a long time to communicate one signal to the other, from one place of the universe to the other. So yeah, then DPI 209 raises another of those interesting questions, like what about society that has done away with economics to pursue science for gaining knowledge and just provides everything for free? Yeah, who knows? So um, okay. Larry says about the edge on spindle galaxy at today astronomy picture of the day. Do you know if the diffuse light by the galaxy is stars or dust or gas of an optical artifact? I don't know because I haven't actually checked it. So I will have to read and check it out. So I don't know. Maybe I can quickly go, but and see if I can see something by first. Just figure out something when I look at it. But let's see. Mhm. we're not seeing edge on as an edge on galaxy. Huh, I would think that that diffuse light is coming from the gas of the galaxy, and I would think that the stars, if it's a spiral galaxy, most of the stars are actually in the arms of the galaxy. So Paranor 001 asks, do you think the discovery of the lake will affect InSight at all? Um, I'm not sure, but I would think it would. It would definitely change maybe the priorities depending on first on what the science objectives that InSight already has. Like secondly, like how, if anything, how good the quality of the data that it could take in theory. I don't know exactly what the details on where InSight is gonna be, and if he could actually tell us about this type of it could take data that would be useful to for us to figure out more about this type of lake or sub undersurface structure. um, if we actually went ahead with the breakthrough starshot, would another civilization be able to pick up the laser radiation? um, they might, if they have, again, if they have developed a technology that is capable of detecting this type of light. But again, we have all this, I mean, vastness of the universe and all these distances to surmount. That what if, again, we send a signal and it's picked, and then how do we know that they have actually picked it and they are gonna reply to us? And then sometimes you read in science fiction, but maybe not in science fiction, but in educated guesses, like for in books by Kip Thorne or even by Stephen Hawking, and then they usually tells us that of course we point out that we have this limit by the speed of light, but then we hope that maybe an advanced enough civilization has been able to come out with a quantum theory of gravity, and they have been able to maybe concentrate such amount of energy in a space-time that they could create these theoretical objects that are called wormholes, or like shortcuts in a space-time that could actually get us ahead from that limit that the speed of light is giving us in space. Again, these are ideas that are speculative. They have a theoretical background, so there are solutions in the theory that actually could produce this type of objects. But then to attain this, or we don't know if there might be a civilization that is going to be able to even create a technological device to produce this type of things and to create a wormhole or something like that. And then in that case, maybe they can get the signal and then communicate and come back to us. But then there comes the Fermi paradox again. Okay, why haven't we seen anything if there is something out there? So, yes. I want to live in the first Matrix, the perfect heavenly world. I can handle it. Larry is leaving us, so bye bye. Thank you for being with us. And then Dell1337 points out we need a warp drive capability. That'd be cool. But yeah, maybe Paranor 001 points out hyperspace. We gotta get on it. Yes, that's what I was thinking of, the hyperspace. But yeah, okay, guys. So I think it's time to say goodbye for today. It was a very interesting conversation. I always like your questions and enjoy your comments, and then we get to chat a little bit about the news and more importantly, the consequences of the news. But well, thanks again. Thank you so much for watching. And this has been the Daily Space. It's a production of CosmoQuest, created by the Astronomical Society of the Pacific. If you like this show, please give us a follow, or if you want to sustain our efforts, please consider subscribing. Um, so yes, we'll be back tomorrow, the Daily Space, and every day of the week at 1 p.m. Eastern, 10 a.m. Pacific, and 6 p.m. London. And tune in tomorrow. And bye bye, everyone.